हेलो स्टूडेंट्स, आपका स्वागत है हर घर बने पाठशाला में। तो इलेक्ट्रोस्टैटिक्स हम स्टडी कर रहे थे और आज बहुत ही इम्पॉर्टेंट जो कार्य करने वाले हैं हम लोग वो है न्यूमेरिकल प्रॉब्लम्स। बिफोर गोइंग टू द न्यूमेरिकल प्रॉब्लम we must revise some important formulas we have earlier discussed, and in the today's study work we will have some steps to solve the numerical problem. Then we will practice the numerical based upon the electric potential. First we have some revision work. Electric potential, it is a physical quantity that determines the degree of electrification of a body. Electric potential at a point in electric field is defined as work done in moving a unit charge from infinity to that point against the electrostatic force irrespective of the path followed. W infinity to B divided by Q naught, that is equal to Q by 4 pi epsilon naught R equal to V. V, that is a potential, that is equal to work done per unit charge. Then we have discussed the equipotential surface at every point of which potential due to charge distribution is same, that is a equipotential surface. And electric field, that is defined as negative potential gradient. E is equal to minus dV upon dr, or dr will be equal to minus dV upon E. Then the electric potential energy. Work done in moving a charge Q from infinity to a point in electric field against electric force, that is called the electrostatic potential energy. W is equal to QV. W will be equal to potential energy. 2 point charges. The potential energy is given as 1 upon 4 pi epsilon naught Q1 Q2 divided by R1 vector minus R2 vector magnitude, or simply this potential energy of the 2 point charges will be equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R12. Or for the case of 3 point charges, potential energy is given as 1 upon 4 pi epsilon naught Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R32. And for the n number of charges, potential energy of n number of charges, that is 1 upon 2 whole multiplied by 1 upon 4 pi epsilon naught summation I is equal to 1 to n summation I j is equal to 1 to n, where this I is not equal to j, into qi qj divided by rj minus ri vector whole magnitude. Now the work done on an electric dipole in uniform electric field. When electric dipole is placed in uniform electric field, it experiences torque, and that torque tend to align in such a way to attain the maximum equilibrium, and that work will be stored in form of the potential energy. Potential energy U will be equal to minus Pe cos theta. Before discussing some numerical problem, we have to get the information how to solve the numerical problem. There are few steps regarding the solving the physics problem. So many students think that in physics there is a lot of mathematics involved. There are not so much difficult mathematics involved here in the physics. We must take some information from the question and try to solve that. There are few steps. First, read the question carefully. To solve a numerical problem in the you have to read the question carefully. What is there? What is he asking from the question? Read all the information given in the question carefully. Then try to understand the situation. What is the situation of that question? What the situation is given in the question, and what you have to find out from that question. Then organize the information. What kind of information is given? In the numerical problem, there are some given values are there, and some information is given that something is there, and in what situation it is gathered that information and organized all the information. Then sketch the sense. Then draw the figure from the given information. What he is asking from the question. If the dipole is given, then draw the two charges and make a dipole. Equipotential surface on the equatorial line or the axial line. Draw all that information. A hexagon is given or the cube is given, whatever is given, sketch that. See. And from the question, there are so many things given. and their units are also given. Verify the units. Sometimes the question is asked in a tricky way. He make one unit is different from the other, then make that unit in a single situation. We mostly use the SI system of unit to convert the whole of the units into the SI system. Then consider your formula from the question. What is asked that have to be solved by some formula. Write down that formula. Sometimes the same question can be done by the many ways. There are a number of the formula can be used in the question. Then consider the formula which can be put in your situation. There is some values are given. If that values fit in a formula, that the formula is used there. If some values from the formula is not given there, then you have to find out that value from the given information first, and then put the values in the given in the formula. Okay, then solve the simple mathematics is involved, dividing, multiplication, etc. is involved there. Solve the question and then verify the whole result. Once again, give a glance at the question you have solved, you have solved, verified that. It take hardly not more than that of the 3 to 4 second, 4-5 second. Verify and practice and practice and practice more questions. Okay, then we come to some example relating to the electrostatics. First we take an example that a cube of side B has charge Q at each of its vertices. Determine the potential and electric field due to this charge array at the center of a cube. Here, what is given there? There is a cube, have the side. Then draw the cube having side B. Okay. Draw the charge symbolized at the each vertices. Determine the potential. What is asked? He is asking about the potential and electric field due to the arrangement of charge at the center of cube. He is asking charge at the center of cube. Okay, then how to solve this? First, identify the situation of the location of the center of the cube. Length of cube is given as B. This is B, this is B. Then this diagonal will be equal to under root 2 by B. Under root 2 B, sorry. B, this is B, and this will be equal to, by using the Pythagoras theorem, we will find out this is under root 2 into B. And now from this figure, you will find that this is value have the under root 2 and this have the value B. Then this diagonal will be equal to under root of 3B square. Using the Pythagoras theorem in this figure, you will find that this diagonal will have the value under root 3B square, or B under root 3. And what is asking? He is asking the center. Now the center of this diagonal will give the center of this whole cube. That means this diagonal will have the half value at the center. Then the distance of any of the vertices from the center of cube, that will be equal to under root 3 by 2 into B. Okay. Then what is to find? Determine the potential. We have located the position and we have to determine the potential. V will be equal to 8. Why he multiplied by 8? There are the 8 charges at each vertices. These are the total number of charges at corner are 8. Then 8 multiplied by 1 upon 4 pi epsilon naught Q by R. Total charge will be equal to Q 8. So then this 8 multiplied by 1 upon 4 pi epsilon naught multiplied by Q divided by R. R we have calculated is under root 3 by 2B. Okay. Then after simplifying, V will be equal to 4Q divided by under root 3 pi epsilon naught B. Okay. Then he has asked about the electric fields due to charge. Electric field will be equal to 0. Why? As electric field at the center due to charge at any corner of the cube is just equal and opposite to that of another charge at diagonally opposite corner of the cube. Again, understand this line. Electric field at the center due to charge at any corner of the cube is just equal and opposite to that of another charge at diagonally opposite corner of the cube. Okay. Then come to the another example. A regular hexagon of side 10 centimeters has a charge of 5 microcoulomb at each of its vertices. Calculate the potential at the center of a hexagon. Here what is given? Hexagon. Side is given 10 centimeter. Charge on each side vertices is given as 5 microcoulomb. Okay. Then what we have to calculate? Calculate the potential at the center of a hexagon. Okay. Then first draw the hexagon. Figure they have the 8 equal sides and 8 equal charges at the vertices of a hexagon. Okay. At vertices of Q charge at the vertices of a hexagon. Okay. Here charge given is a 5 microcoulomb. Then convert first into the coulomb. Microcoulomb, micro they'll have the that have the value 10 to the power minus 6. Then multiplied this microcoulomb by the 10 to the power minus 6, it will be converted into the coulomb. Charge will be equal to 5 into 10 to the power of minus 6 coulomb. Then sides of the hexagon are equal. A, B, C, D, E, here they have equal value that have the side 10 centimeter. Each side is of 10 centimeter. Then distance of the center of diagonal from any vertices, mathematically that is equal to the side of the diagonal. That means this value will be equal to 10 centimeter. Center from any vertices will be equal to 10 centimeter. Okay. Then we know that potential is given by Q upon 4 pi epsilon naught D. Okay. Then here epsilon naught that has the that is permittivity of the free space, and 1 upon 4 pi epsilon naught that have the value 9 into 10 to the power of 9 in Newton per centimeter square per meter square. Hexagon, there are 6 charges, then multiplied whole equation by the 6 charge. Total charge will be equal to 6 into Q. Okay, total charge that will come out to equal to 6 into Q. Then potential will be equal to 6 multiplied by the value of this 1 upon 4 pi epsilon naught, that is equal to 9 into 10 to the power 9 into 5 into 10 to the power of minus 6. 5 charge is 5 into 10 to the power of minus 6. And the distance, okay, that is 10 centimeter. Convert into the meter. That will have the value 0.1 meter. That give after calculation, this gives the value of potential at the center of hexagon, that is equal to 2.7 into 10 to the power of 6 volt. Another example is a spherical conductor of radius 12 centimeters has a charge of 1.6 into 10 to the power of minus 7 coulomb distributed uniformly on its surface. What is electric field? Spherical conductor have the radius of 12 centimeter and charge distribution, that is 1.6 into 10 to the power of minus 7 coulomb on its surface. What is electric field? We have to find out the electric field. First case is inside the sphere, second case is just outside the sphere, and third case is at a point 18 centimeter from the center of the sphere. Okay, first case, let us take the first case. Inside the sphere, radius of sphere that is given is 12 centimeter, that is equal to 0.12 centimeter. Okay, 12 centimeter is converted into the meter, 0.12 meter. Charge is uniformly distributed over the conductor. Then charge given is 1.6 into 10 to the power of minus 7 coulomb. Okay, in the first case we have to find the electric field inside the sphere. Electric field inside the spherical conductor, that is 0. Okay, electric field inside the spherical conductor, that is 0. This is because if there is a electric field inside the conductor, then charge will move to neutralize it. Okay, then the second case, just electric field just outside the sphere. If E is electric field outside the sphere, then we know that on the surface of the sphere, electric field is given by relation Q upon 4 pi epsilon naught R square. Epsilon naught, that is permittivity of the free space, and 1 upon 4 pi epsilon naught have the value 9 into 10 to the power of 9 in Newton meter square per coulomb square. Then this E will have the value, substitute this value 1 upon 4 pi epsilon, that is equal to 9 into 10 to the power of minus 9, and Q have the value 1.6 into 10 to the power of minus 7, and the R have the value 0.12 square. After calculation, doing the calculation, then it come out to be equal to 10 raising power 5 Newton per coulomb. Therefore, electric field just outside the sphere, that is equal to 10 raising power of 5 Newton per coulomb. Third case, at a point 18 centimeter from the center of sphere, then we come to the point outside the sphere at a distance of 18 centimeter. First convert this 18 centimeter into the meter. D is equal to 18 centimeter, that will be equal to 0.18 meter. Electric field outside the sphere at a distance outside the sphere, that is given by the relation Q by 4 pi epsilon naught D square. Okay, D is have the value 0.18, then substituting the value of 1 upon 4 pi epsilon naught, that have the value 9 into 10 to the power of 9, then charge have the value of 1.6 into 10 to the power of minus 7 divided by this value 18 into 10 to the power of minus 2 whole square. After calculation, this come out to be equal to 4.4 into 10 to the power of 4 Newton per coulomb. This is the electric field just outside the sphere. Then we take another example. If one of the two electron of the hydrogen H2 molecule is removed, we get the hydrogen molecule ion H2 positive, have the value positive. In the ground state of an H2 positive, the two protons are separated roughly 1.5 angstrom and electron is roughly by 1 angstrom from each proton. Determine the potential energy of the system. Specify the choice of 0 of potential energy. Simple H2 molecule. If we remove the electron, it becomes positive. Okay. Here it is the case of 3-point charges. 3-point charges, potential energy stored in the system. It is the system of 3 charges and potential energy stored in the system. Positive charge, negative, and another positive. Potential energy of the 3-point charges, that is given by 1 upon 4 pi into Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. Distance of separation is between this negative and positive charge, that is 1 angstrom, and that of 2 positive, that is 1.5 angstrom. Then substituting these values, first take the case of positive and negative this way. Okay, then take this positive and positive, and then negative and positive. Okay, then it will be equal to 9 into 10 power 9 e into minus e divided by 1, e into e divided by 1.5, then e into minus e divided by 1, whole multiplied by 1 upon 10 to the power of minus 10, because 1 angstrom is equal to 10 to the power of minus 10 meters. Okay. Then after calculation, E square will be taken outside, that have the value, E have the value 1.6 into 10 to the power of minus 19 whole square, because E into E will be E square. This will go above minus, then when it is multiplied above, then it will have the value 10 to the power of 10. And after simple cross multiplying and taking the LCM, this value will be equal to minus 2 upon 1.5. Okay. After simple multiplication, this is in the joule, and convert into the electron volt, divide it by the 1.6 into 10 to the power of minus 19. Then potential energy that come out to be equal to minus 19.2 electron volt with 0 potential energy at infinity. Okay. Then we take another example. In case of a hydrogen atom, electron, proton are bound at a distance of 0.53 angstrom. Estimate potential energy of system in electron volt, taking 0 of the potential energy at infinite separation of electron from the proton. Second thing, calculate what is the minimum work required to free electron, given that it's a kinetic energy in orbit itself. Orbit is half the magnitude of potential obtained in case of A. First case that is used here. And what third thing we have to find out, what is the answer, what are the answer A and B above if 0 potential is taken as a 1.06 angstrom separation. Okay. The distance between electron and proton, that is given as a D is equal to 0.53 A naught. Charge on electron, that is a minus 1.6 into 10 to the power of minus 19 coulomb. And charge on proton, that is positive, 1.6 into 10 to the power of minus 19. Okay, then come to the first question. Potential at infinity, that is 0. Then potential of the system of proton and electron, that will be equal to potential at infinity minus potential energy at infinity minus potential energy at distance d. It will be equal to potential energy at infinity, that is 0, and at the separation, that will be Q1 Q2 divided by 4 pi epsilon naught d. Substitute these value. of 1 upon 4 pi epsilon naught, that is equal to 9 into 10 power minus 9 10 power 9 into 10 power 9 Newton meter square per coulomb square. Then potential energy after substituting the value of D in this equation, that come out to be equal to minus 43.7 into 10 power minus 19 joule. Then convert this joule into the electron volt. We know that 1.6 into 10 power minus 19 joule, that is equal to 1 electron volt. Then potential energy, divide this value by 1.6 into 10 power minus 19. It come out to be equal to minus 27.2 electron volt. Therefore, potential energy of system is a minus 27.2 electron volt. Then come to the second thing. What is the minimum work required to free electron, given that kinetic energy is in the orbit is half of the magnitude of potential energy? Okay. Kinetic energy is half of the magnitude of potential energy. Then kinetic energy will be equal to the potential energy we have calculated is a minus 22.7. Half will be equal to 13.6. The total kinetic energy, that will be equal to 23.6 minus 27.2. 13.6 minus 27.2, that will be equal to 13.6 electron volt. So therefore this energy is required, minimum work equal to the work. Minimum work required to free electron is 13.6 electron volt. Okay. When the potential energy is taken, D1 is equal to 1.06 A naught. The potential energy of system, that will be equal to potential energy at D1 minus potential energy at D. D1 is given as 1.06 and D we have already calculated. Then potential energy at D1 will be equal to Q1 Q2 divided by 4 pi epsilon naught D1 minus this potential energy at D minus 27.2 electron volt. After calculation by substituting the value of D1, that is equal to 1.06 into 10 power minus 10. A naught is converted into the meter by multiplying the 10 power of minus 10. This value come out to be equal to 21.73 multiplied by 10 power of minus 19 joule. Then convert this value into the electron volt. This come out to be equal to 13.58 electron volt minus 27.2 electron volt. Give the value 13.6 electron volt. Okay. Then come to the another example, that two charges 5 into 10 raising power of minus 8 coulomb and minus 3 into 10 raising power of minus 8 coulomb, located 16 centimeter apart. At what point on the line joining the two charges the electric potential is 0? Take the potential at infinity to be 0. Here the given values are Q1, that is 5 into 10 power of minus 8 coulomb, and Q2, that is equal to minus 3 into 10 power of minus 8 coulomb. And the separation that is given is 16 centimeter, that is equal to 0.16 meter. Okay. Consider the point P on the line joining the two charges. Here, anywhere between the two charges, that here we take the P at a distance of R from Q1. Then potential at P will be 0 when the sum of the potential at this P due to this Q1 and due to this Q2 will be equal to Q1 upon 4 pi epsilon naught R plus Q2 upon 4 pi epsilon naught D minus R. Total potential will be equal to 0. Then V will be taken 0. The value come out to be equal to Q1 upon 4 pi epsilon naught R will be equal to minus Q2 upon 4 pi epsilon naught D minus R. Take this value to the side, this side. Then V is taken 0. then Q1 upon 4 R will be equal to minus Q2 upon D minus R. This 1 upon 4 pi epsilon naught, that will be cancelled. Then substituting the value of Q1 and Q2, 5 into 10 power of minus 8 or divided by R will be equal to minus of 3 into 10 power of 8 divided by 0.16 minus R. This give the value 0.16 divided by R minus 1 will be equal to 3 by 5. Will give the value 0.16 divided by R will be equal to 8 by 5, or R come out to be equal to 0.1 meter, or this converted into the centimeter then is come to be equal to 10 centimeter. Therefore, potential is 0 at a distance of 10 centimeter from the positive charge between the charges. Now take this point P outside. Suppose that P is outside the system of two charges at a distance S from the negative charge. Where the potential is taken 0. Q1 is at a distance of P from this point. Then total potential will be Q1 upon 4 pi epsilon naught S plus Q2 4 pi epsilon naught S minus D. This distance, remaining distance, that is S minus D. Potential will be taken equal to 0. Then the Q1 upon 4 pi epsilon naught S will be equal to minus Q2 upon 4 pi epsilon naught S minus D. 1 upon 4 pi epsilon naught, that will be cancelled. Give the value Q1 upon S will be equal to minus Q2 upon S minus D. Substituting the value of the Q1 and Q2 and the D, we get the value 1 minus 0.16 divided by S will be equal to 3 by 5, or 0.16 by S will be equal to 2 by 5, or after simplification S come out to be equal to 0.4 meter, that is equal to 40 centimeter. Therefore, potential is 0 at a distance of 40 centimeter from the positive charge outside the system of charges. Take the another example. Charge of 8 millicoulomb is located at origin. Calculate the work done in taking the charge of minus 2 into 10 power of minus 9 coulomb from the point P 003 centimeter and from the Q 040 and via the R 0.6 centimeter 9 centimeter. Here this is the position of the P and this is the position of Q. P X, Y, Z are taken on the Z axis. Here at origin the Q charge is positive 8 millicoulomb and P is have the coordinate 003 on the Z axis, and Q 043 Y coordinate is there. Then on the Y axis we take the Q 040. Another point is R 069. As electric field is, that is conservative one, so work done in moving a charge in electric field, that is independent of the path chosen to move the charge in the electric field and depend only on the electric potential difference between the two charges. That means this R have no meaning here. It depends only on the P position and Q. So work done will be from P to Q will be equal to Q naught into VQ, potential at Q, minus potential at P. Q naught multiplied by 1 upon 4 pi epsilon naught Q upon R OQ, this value, and 1 upon 4 pi epsilon naught Q upon R OP. Okay. Q1 is and 4 pi epsilon naught, that is taken common. Inside will be 1 upon 4 pi, 1 upon R Q OQ minus 1 upon OP. Substitute the value of the 1 upon 4 pi epsilon naught Q and Q naught. And here the value of 1 upon OQ will be equal to 4, 1 upon 4, and this 1 upon R upon OP will be equal to 1 upon 3, whole multiplied by 1 upon 10 to the power of minus 2. Okay, centimeter is to be converted into the meter, then multiplied by 1 upon 10 to the power of minus 2. This gives the value equal to 12 into 10 to the power of 1 joule. That means work will be equal to 1.2 joule. Okay, that was all for the numericals. Solve more numerical problem from the textbook. In the next day study plan, we will discuss the conductor, insulator and dielectrics and the behavior of the conductor in electric field. Enjoy your study. Thank you.